right, so in this video, we're going to do linear inequalities from word problems. So the first one we're going to look at is this question about Joe and a chess tournament. He wants to score at least 6.5 points. That means that is the minimum number of points that he feels comfortable getting. So I'm going to start building this equation or this inequality right now. Since 6.5 is the smallest number of points he wants to get, that means all of the ways that he can get the points need to get him more or at exactly 6.5. So 1 point for each game he wins. A win is a W. So I'm going to put a 1W or just W. And then half a point for any game that ends in a draw, and draw will be D. So then I'm going to put plus, and I didn't give myself enough room, W plus 0.5 D. And this is the inequality that represents Joe's scenario. Next one we're going to look at here is about a yearbook. So they're giving the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. So that's my minimum. And the way that we're going to get that $28,000 has to be more or exactly $28,000. So a yearbook is 35 and a ring is 140. So I'm going to make X the number of yearbooks and Y the number of rings. And my video will catch up in just a second. So X goes with yearbooks, so it's 35X plus 140Y. And then our goal is to figure out a possible combination of yearbooks and class rings that the junior class would need to buy in order to get their picnic. Well, $28,000 is a lot of money, right? So I'm going to say, let's say that we're going to do, and I'm doing this as an estimation. Let's say that we're going to do 50 rings. So if I do that, well, then my equation would be 35x plus 140 times 50. And my answer has to be greater than or equal to 28,000. However you want to do 140 times 50, as long as it is without a calculator. That tells me 35x plus 7,000 needs to be greater than or equal to 28,000. Then I'm going to subtract 7,000, so 35x needs to be greater than or equal to 21,000. And then I would divide by 35, and again, however you're going to do that, but it does need to be without a calculator. Keep that in mind. That tells me it would have to be greater than or equal to 600. So that would be 50 rings and 600 yearbooks. Now you could have chosen 100 rings to start with. You could have chosen 200 rings to start with. It would have been the same process using this inequality. Now that's if we did it without a graph. Let's say we did it with a graph. Curbside recycling is going to remove up to 50 pounds of plastic bottles and paper products each week. So they want us to describe or write an inequality that describes the pounds. We're also going to graph this. So I'm going to say that X is the pounds of plastic and Y is the pounds of paper. So this is pounds of plastic. Oop, let me move this. And then this would be pounds of paper. So ultimately, these two things combined together are up to 50 pounds. If I have more than 50 pounds, they're not taking it. So that would mean that X plus Y is less than or equal to 50. Now, since this is a standard form inequality, I can find the X and Y intercepts. And it's nice because neither of these have a coefficient. So my x-intercept is going to be 50, and my y-intercept is also going to be 50. So I have a point here. I have a point here. I don't know where my ruler went, so I'm going to have to use a makeshift ruler. Now, since this is an equal to, I'm going to use a solid line, and it's up to 50 pounds. That means I can't go over 50 pounds. Well, these are all of my possibilities for the pounds of plastic. These are all of my possibilities for the pounds of paper, and it can't be more than 50. So this line is the maximum. So it would be all of this in here as options for my trash pickup. So for example, I could do 15 pounds of plastic and 30 pounds of paper, and that would still meet the requirements for this curbside recycling service. So we're raising money for the Red Cross, $3 for a fruit basket and $5 for a box of cheese. So I'm going to make X my number of baskets, and that's fruit, and Y is the number of boxes of cheese. And we want to raise more than $100. That means $100 exactly is not going to cut it. So $3 for a fruit basket, $5 for a box of cheese, and that has to be more than $100. Can't be exactly $100. Now it wants 3 possible combinations. So that means I'm going to do some pulling out of the air of some numbers for baskets of cheese, baskets of fruit and boxes of cheese. Now, since the boxes of cheese are more, I'm going to say let's start by doing 15 boxes of cheese. So that's going to be my first one. Well, then that would be 3x plus 5 times 15 being greater than 100. And again, just as a reminder, these are all examples of questions that could be on the calculator inactive section. So this would be 3x plus 75 being greater than 100. Subtracting 75 tells me 3x needs to be greater than 25. Now, yes, 25 divided by 3 is a fraction. It is not a whole number. But since these represent baskets of fruit, my value for x needs to be bigger than the decimal because I cannot sell a decimal box of basket of cheese or basket of fruit. So 8 times 3 would be 24. 9 times 3 would put me over, so that's fine. So that tells me my x value has to be bigger than 8. Now, these can only be whole number answers because it is a tangible object that cannot be a fraction. So if I'm selling 15 boxes of cheese, it would also be, not 8 baskets of fruit. It would be 9 baskets of fruit. And that would meet my requirement. I could also do 15 boxes of cheese and 10 baskets of fruit or 12 baskets of fruit. That will still put me over that $100. Let's say we only did 10 boxes of cheese. Well, that would be 3x plus 5 times 10 being greater than 100. And again, no calculator. 3x plus 50 greater than 100. Subtracting 50 tells me that 3x has to be more than 50. Now again, I understand that this is a decimal answer. The closest that I'm going to get, let's see, 3 times 15 gives me 45. 3 times 16 would give me 48. So, no, not 3 has to be bigger. So x has to be bigger than 16, which means the lowest number of baskets of fruit I could pair with 10 boxes of cheese and meet my goal is 17. I mean baskets of fruit. I don't know if I said that right. Now, if I wanted to quickly come up with a third one, I could do 17 baskets of fruit and 11 boxes of cheese. And I know because of the work I did here that that would definitely meet that $100 requirement. All right, last one. We're going to a bookstore. We have $60 in cash. If I'm only going to the bookstore with cash, I cannot spend more than $60. That's the most. I could spend all 60, but I can't go over. So we're going to make X the number of hardcovers and Y the number of paperback books. So $12 per hardcover and $5 per paperback, and I can't spend more than $60. So let's say they want 3 combinations again. Let's say I buy 5 hardcover books. Well, 12 times 5 plus 5y being less than or equal to 60. Well, if I buy 5 hardcover books, that is $60 right there. That means I can't buy any paperback books because I would have 5y being less than or equal to 0, and I can't do anything with that. So that would be 0 paperback books. So that's a good way for me to know, well, I can't buy more than 5 hardcover books. So if I want to be able to buy any paperback books at all, I have to buy less than 5 hardcover books. So let's do 3 hardcover books and see how many paperbacks we could buy. Well, that's going to be 12 times 3 plus 5y being less than or equal to 60. And again, just as a friendly reminder, this is no calculator. So that's 36 plus 5y being less than or equal to 60. I'm going to subtract 36 from both sides. So that tells me 5y is less than or equal to 24, which does not give me a whole number of paperback books. I realize that this is a decimal, but I cannot buy a decimal of a book. So y has to be less than or equal to 4 in this case. I could not buy more than 4 paperback books if I buy 3 hardcover books. And those are just some examples of ways that I could guess and check and see what different combinations would work for this inequality that we've written.